From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 274, recorded live Thursday, July 7th, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Erik Meijer about the notion of JavaScript being assembly language for the web.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today we're talking to Erik Meijer. He's a partner architect on the cloud programmability team, and I was talking with Erik on email a couple of days ago, and he made a very wise comment. He said, JavaScript is an assembly language. What do you mean by that, Erik?
Well, what I mean by that is that when you write... Well, let me kind of, roll back a little bit. So if you look at things like, .NET or the JVM or even x86, you program in a high-level language that gets compiled into JVM bytecodes or CLR assemblies or x86 binaries, and you run that. Now, if you look at JavaScript, it is, in some sense, this same thing. The people get confused when they see, curly braces and something that looks like a high-level language. But really, in my view, JavaScript is the same as JVM bytecodes or CLR assemblies. So you take a high-level language and you map it down to JavaScript, and every browser has a JavaScript VM. So really JavaScript, in some sense, fulfills the promise of write once, run everywhere. But it's just that, like, if you disassemble a CLR assembly or a JVM class file, you get something that looks like assembler language. And when you look at JavaScript, people often see something that looks like a high-level language, and then they get confused. But really, they're kind of the same thing.
Mm-hmm. The postulate that I kind of propose in my blog post on this topic was that we should not be looking at what comes down to the browser for reference at all. Basically, it's simply it could be a mess. It could be a mess of JavaScript. It could be a mess of markup. It really just doesn't matter. And when I threw that out there, some people immediately understood what I meant, the idea that the development language, the development environment could be in any number of languages, of development styles. But other people kind of, I feel, confuse the idea of minification and compression. And I'm not quite sure how to get people straight on this. I kind of felt like the transport mechanism and the minification and the compression is one thing, like HTML is all being zipped up, and no one sees that because when you say view source, it's being unzipped. But help me understand this idea that, I'm talking about more than just minification and compression. I'm talking about the environment that you write it in might not even be HTML and CSS.
That is correct. So let's start, really simple, right? If you look at JavaScript, and, you look at, say, popular book, JavaScript, The Good Parts, what you will see there is that in order to write JavaScript, if you go beyond simple, button click handler or, simple things like that, you have to do a lot of boilerplate code. So in order to simulate namespaces, in order to simulate classes, in order to do private fields, there's a lot of boilerplate code, which is very similar to assembly code. So JavaScript has very few primitives. It has very powerful primitives, but you have to kind of build everything from scratch. And so that's why people have like a lot of conventions to write JavaScript. But now you can say, well, why do you write these things by hand? Why don't you have some higher level language that generates those things? And so that is kind of the bootstrap that you get. which is different than minification, because now you're kind of using a compiler to generate the boilerplate for you. Now, even if you look at minification, you can also view that as some kind of compilation where the source language and the target language are the same. For example, Google has a tool called Closure, which is a JavaScript minifier and optimizer, which takes your JavaScript and munges it and kind of does all kind of things to it, just in very much the same way as a compiler does. And the fact that the source language and the target language are the same does not really matter. In fact, there's many languages, for example, Haskell, where the compiler works exactly like that. You start out with the Haskell program, and then the compiler, in multiple passes, turns that program into a smaller and smaller subset or more efficient version of your program. And then in the end, you still have a valid Haskell program, but it's in it's more efficient and in a smaller subset. And so it can be further compiled or is easier to run or whatever. So I think the minification, if you just do pure minification and obfuscation, that's kind of the most trivial way of doing compilation. But I do think that also shows the fact that people really, if you do view source, the JavaScript that you see is not meant for human consumption. It's really meant for the VM that runs in the browser to run it.
But don't you think that one of the reasons that JavaScript was so successful and why JavaScript took off was the very idea of view source? I mean, people have said that, well, yes, everything should be minified because it deters decompilation, but it's really only a deterrent. It's not a complete obfuscation solution. It's not like one would really put their intellectual property in JavaScript, minify it, and then think that they were protected. And at the same time, someone said, well, I could save 50 gigabytes a month, but if you do the math, that's like 60 cents on Amazon, so the bandwidth argument falls down as well. There seems to be no good reason other than maybe perception of speed on the client to go and minify JavaScript. And when doing that, you lose any benefit of teaching the audience.
Yeah, well, so I think doing view source might not be the best way to teach people about your program. So I think that is the same. What you see a lot of people with .NET assemblies, for example, they kind of use some tool, some decompilation tool, Resharp, .NET Reflector, or now ReSharper has a tool like that too, in order to understand, the code, what's going on. So I think the source code and the code that you transport to the machine are two different things. So I think if you want people to learn from your code, why have view source? Why don't you kind of have that code somewhere up with comments or in some GitHub repository where people can actually download it and play with it, and there's test cases and so on. I think doing view source is more an accident of I don't know, that was something that the browsers had, and then people may use it to learn about stuff, but in some sense that's the same as looking at a DLL or something like that. So I think you should separate those things out. And the browser, it loads. It's really, think of the browser as it's a regular VM that loads normally. Things come packaged in .exes or in class files
jar
or
files
in
even, yeah.
DLLs, and now it comes, as a string that gets loaded and executed. But that string that gets loaded is not the fact that a human can look at that or view source, I think that's just an accident. That's not the purpose of that.
That's a very interesting statement, that view source is an accident. So there's the issue of combining and minification and basically post-build steps, of course, that prepare stuff for transport. Certainly we could, zip up the entire website and give it a new extension and, call it .app or something, and it would be interesting and it would run within a little virtual machine. But taking the conversation in a slightly different way, some people in the comments on the blog post that I put up about this, someone actually about halfway through said this is the return of Project Volta, and that's something that you were involved in. Can you tell me what that is and why that person would bring up Project Volta?
All right. Yes, I can definitely talk about that. So the idea of Volta was exactly what I just described. You look at the JavaScript and you say, oh, well, that's just one place where I can execute code. Just like x86 is a place where I can execute code, or Silverlight is a place where I can execute code, or take whatever target you have. So what we did is we took .NET assemblies and wrote a JIT, just like you write a JIT that goes to x86 or ARM, and we wrote a JIT that would take .NET IL and JIT that into JavaScript. And so really that literally took the idea of JavaScript is an assembly language to its logical conclusion. And there's really no difference between writing a JIT that takes IL and compiles it to ARM, or writing a JIT that takes IL and compiling it to JavaScript. And I would even argue that JavaScript as an assembly language has a lot of advantages for the compiler writer, because it has it's a very high level assembly language. It has closures, it has exception handling. So even though you have to encode, for example, the semantics of .NET types and constructor calls and interfaces and cast and so on, there's many things where you don't have to encode them in a low level. Let's take, for example, if you want to do exceptions. If you're targeting x86, it has no notion of exceptions, so you have to encode everything yourself at a very low level. When you target JavaScript, you can, if you're lucky, you can target JavaScript exceptions, and now you can kind of layer your exception mechanism as defined by the IL or the .NET specification and map that into JavaScript. A similar project is, and you were playing with that too, as you said, is Google's GWT, where they take Java and they compile that to JavaScript, and trying to maintain the semantics of that. So this idea is quite widespread. Another great example is Script Sharp. This is a project that Nikhil did here at Microsoft. It's slightly different than GWT and Volta, where there you take, in Script Sharp, there's a language, a syntax that looks like C#, but that's compiled to JavaScript. So it's like a new programming language. And there's a whole slew of examples like that. CoffeeScript, I think, is at this point a very popular example of that, where you have like a Python-like syntax, and you compile that into JavaScript. And then there's Objective-J, and there's many. I think this is the hot thing at the moment, where people are taking either existing languages and trying to maintain the semantics of those languages, mapping them to JavaScript as an assembly language, or have a slightly higher level language that maintains much of the JavaScript, style semantics. Let me give you an example of where things get difficult with the IL or when you're doing Java. JavaScript arrays are not really like regular .NET arrays. You can, put in a value not at a numeric index. There's no, array bounds checking. You can, put something, you can access out of bounds elements and so on. So if you're trying to maintain the .NET semantics of arrays, you have to do a lot of work. Just like when you're targeting regular assembler language, you have to do a lot of work to map the high-level concepts onto the lower-level things. So what people do is they say, well, let's try to maintain a lot of the JavaScript semantics, but put some more sugar on top. So those are kind of, I think, two different approaches where, either you have an existing language with its semantics that you map onto JavaScript, or where you're saying, well, let's maintain some of the JavaScript flavor and but build a higher level language on top.
This episode of Hansel Minutes is brought to you by Careers 2.0. Careers 2.0 is a new service by our friends at Stack Overflow. You're probably all familiar with Stack Overflow, the online Q&A resource dedicated specifically to programmers and programming-related topics. Well, the team at Stack Overflow created Careers 2.0 to provide you with access to great jobs and introduce you to a bunch of great companies that you might consider working for, even if you're not currently looking for a job. Think of Careers 2.0 as a programmer profile. It gives you a platform to show that you're awesome by featuring your proudest contributions to Stack Overflow, GitHub, SourceForge, Bitbucket, anything programming related. You can even add your favorite programming books from Amazon.com. Profiles on Careers 2.0 are free. They're easy to get started, especially by importing your LinkedIn profile. However, there's one catch. Profiles on Career 2.0 are invite only. They did this to keep out the spam and have a high-quality environment. Fortunately for you, as a Hansel Minutes listener, I've got your back. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. I hope you like it. Why does, given how quirky JavaScript is, given how unusual it is, I mean, people have said that JavaScript just wasn't designed, it kind of organically grew. Given that the JavaScript that I kind of hated in the early 2000s and the late 90s is so much different than the JavaScript today, some people feel that JavaScript in its kind of organic, strange state is a beautiful thing, and other people say, well, this is just offensive. I have to remember 20 different hacks in order to use it. Why not use a language that was, properly designed? Why not forget about JavaScript? Why didn't Volta and Script Sharp take off? I mean, they have their fans. I know that Script Sharp is still actively developed, and I know that there are a number of projects that have been written entirely in Script Sharp, but I would have to say it hasn't really caught fire. Why not?
Yes, so that's a very good question. I think there's various answers to that. I think if you look at GWT, I think that's very successful. That's used quite a lot. If you look at, but again, if you look at this thing as a compiler or JIT, Google has like a quite large team working on that. I think, if you go to the site, I think there's like about 30 submitters to the project. So you have to think of that in the same vein as, the CLR team over here at Microsoft, or maybe the JVM team over at Sun or Oracle now. It's really, you're writing, or the C# team, you're really writing a compiler or a JIT, which is not, a simple thing, because there's, as I said, there's no real difference between targeting ARM or x86 or JavaScript. So it's the amount of work in order to do that is pretty significant. Now, what happened, for example, with if you look at Volta, for example, one of the reactions that people have is they are looking at the generated JavaScript and they say, "Oh, my goodness, that JavaScript looks really complex and complicated," and they're then afraid that you're losing performance and so on. But what you have to keep in mind is that complexity is there because you want to maintain the semantics of the CLR. So all that code that you generate is there for a reason. It would be the same as if you would look at the output of the CLR JIT, the x86 machine code, and say, "Wow, that is complicated machine code. If I would write machine code by hand directly, I could do it much shorter." Of course, but you're not getting the same, the same value out of that. So it's like it's a trade-off. Now, Script Sharp took and CoffeeScript and those things take a more pragmatic approach where they say we're not trying to maintain the semantics of an existing language, but we're defining a new language such that the JavaScript that you generate is not that far removed from the source code, and so the kind of the difference is less. But
so you're saying that the distance, that the intellectual leap that has to be made from what I'm writing to what is outputted is less. There's more of a one-to-one mapping.
It's not so much the one-to-one mapping, but it's not that you're let me say let me give you a concrete example. So in the CLR you have abstract base types, interfaces, inheritance. There's a certain semantics of how constructor calls are made. In order to maintain that semantics, you have to, and JavaScript has a prototype-based inheritance. So now, in order to guarantee the same semantics as when you run your C# program compiled to JavaScript or compiled to x86, you have to generate some fairly, or think of generics, for example. JavaScript doesn't have generics. So you have to generate some fairly hairy JavaScript. And so if you look at what other, and so the more you're trying to maintain an existing language, the bigger that distance is. It's not that it's one-to-one, but it's like JavaScript has certain assumptions about what its base type system is. And so if you layer a language on top of that kind of maintains that same flavor, so it's like it's an prototype-based inheritance, then that translation is less convoluted in yes. some ways.
It's less dramatic.
Yes.
Why do you think that GWT has become successful, at least certainly within Google? Many of their applications are written in GWT. Also, many are written in Clojure. While people on the Microsoft side look at layers of abstraction like web forms and lament it. I drew a comparison in my blog post that resonated with some people, but other people thought I was being intellectually dishonest when I said that this is similar to view state. And in that, some large blob comes down that provides value, but that value is unclear. I either accept that this is there for a reason, or I lament the fact that it's there. And I think that when I see a giant blob of state management JavaScript code, I am reminded of view state, and I feel like, certainly not as a view state apologist, but someone who realizes that view state provided a purpose and a value. It seems like web forms could be expressed in the same way that GWT and these other server-side things are. Maybe it was before its time, or maybe it was not complete enough to solve the problem.
Yeah, so I think you're touching upon some kind of very interesting dilemma, really. So the thing is that when you're abstracting from the underlying, so when you're assuming JavaScript is an assembly language, you're making certain assumptions that you're trusting the compiler to do work for you, and it's the same as like when you're using managed code. you're saying, okay, I'm trusting the system to do garbage collection for me and JITting for me. So you're really kind of, giving trust into the compiler and the runtime, and it takes care of details that you don't want to think about.
Exactly.
Now, you can take the same analogy in the managed world, where people are saying, oh, but I want to use C or C++ because I want to have full control over my memory allocation. I don't want to rely on a garbage collector. I want to kind of write close to the metal. I think you see the same thing here with JavaScript. It's like, if you're using something like GWT, you're really giving away control of a lot of these aspects to the compiler. Where some people want to have more full control, they want to be closer to the metal. So I think you will always have two camps where, certain people want or need to have full control and need to be close to the metal, whereas others, they can work in a high-level language. Now, I personally believe that if you look at something like GWT or what we tried with Volta or with Script Sharp, is that when you have a good compiler, just like with C, there's very few people that can write assembly language that kind of can compete with a good compiler. And especially, you cannot beat the productivity aspect. You can write more lines of code, and you can be more productive in a higher level language. And so it's that trade-off. So sometimes, and just like, sometimes maybe even if you're using C#, you might want to write some things in native code and interrupt with that. I think, you will see the same thing in when you're using JavaScript, that you might want to, drop down into JavaScript to do something that's kind of performance critical, and do the kind of more higher level programming in a higher level language.
So do you think that the development world online is splitting between those that wish to write assembler, or in this case JavaScript and jQuery, and those who want a higher level language? Or do you think it's split more in terms of there are applications and there are websites, and people will write their websites in HTML and JavaScript, and people will write their applications in something else?
That's another great question. I think so. As I said, I think this is like a very multifaceted question, because if you look at JavaScript, people look at JavaScript and it looks like a very high-level language. They see curly braces, they see functions, and so on. So when we did Volta, and I'm pretty sure that the GWT people and the Script Sharp people get the same remarks too. They say this is wrong. You're taking IL, which is a low-level language, and you're translating it into a high-level language. But looks are deceptive, because even if you look at Microsoft at the IL, the .NET IL or Java class files, that looks like a low-level language. But really, the fact that we have things like .NET Reflector, really the IL, it looks like assembler, but it's just a different representation of a C# or a Visual Basic program, because you can decompile it very easily. It's a different view of the same high-level code. So I would argue that Java class files or .NET assemblies are higher level than JavaScript. But people don't perceive it like that, because JavaScript looks so much like a high-level language. So that's one aspect. Then the other thing that you bring up is a very good point, is the difference between applications and websites. And there you get into the whole business of, search engine optimization and so on. It's like when you're using a search engine, how do you find your website or your application? Really, I think most websites are, if your website is not really static, it's really an application. If it's doing interesting computations. And I think things will move more and more to an application-like experience, where like if you look on a lot of phones, and you're using like high-level libraries, you don't really see that this thing was written in HTML and JavaScript. It's not a website anymore. It's not a document. And so this is an interesting thing. I don't know how it will play out, but I think people will want to have a way where the search engine can find their whether you call it an application or a website. That is the way that people find things besides the App Store. And maybe the App Store is for applications. App stores are replacing search engines, because now there's metadata that in the App Store you search on these things in a different way.
Yeah, I definitely I can hear a struggle in your voice, because we haven't arrived yet. We're literally at the inflection point, and I think that's why there's so much kind of concern and paranoia and kind of tumult happen in the community, because you're describing that soon we'll package up HTML and JavaScript and we'll look at it more as an application, and that sounds like Flash or Silverlight. I mean, Silverlight is a runtime within the browser that takes a manifest of resources and code and zips it up and sends it down. The only difference is that it's Microsoft's product and not a standard. But at the same time, people who are really good at Silverlight have said that, as I lament issues in HTML and JavaScript, the Silverlight people are like, we don't have this problem. This is a solved issue. And I think that's what happens when something is designed like Silverlight versus something that grows organically over many, many, many years, as HTML and JavaScript has been. It's going to be an interesting ride, and it'll be even more interesting to see, are we going to be able to declare victory at some point, or will we always have this not quite finished feeling that the web has?
Yeah, that is a good point. When you mentioned Silverlight, for example, in Silverlight, there's no way you can do view source, right? You right click and then you get a little pop-up that says Silverlight usually, and there's no view source and so on. And again, yes, that's taking this idea of it's really an application that runs inside the browser, and that is the thing that I really I'm really struggling here, because there are certain things that are where you kind of browse the web, where it's really like documents with hyperlinks that you click on. It's more like a book or something. Whereas in other cases, it's a mixture. You have a page that has maybe a map on it, or interactive graphs and visualizations. Or you have things where that's just purely an application, like when you have a mail client like Outlook Web Access or Gmail or Hotmail. That is the fact that runs in a browser. It has nothing to do really with a document or HTML, right? It's like you're really using that as an application. I mean,
yep.
I don't know whether people will kind of right click on OA and hope to learn something about the code, or even, view that thing the same as going to a website.
Well, yeah. I mean, some people split the web up in terms of applications and documents. Others might say, well, there are things I can do a view source on and learn something, and there are things that I can't. But it's going to be interesting. Many, many people believe that the web was successful because view source allowed a new person to learn about how it worked. And if the entire web turns into zipped up, obfuscated bundles of something, it's going to be a little bit more of a barrier to entry for the average person to start playing around. But thank you so much, Erik, for taking the time to chat with me about this issue. I think we don't have any conclusions, but we've definitely introduced a lot of new questions.
Well, which keeps life interesting. If all the questions were answered, then what was there left for us to do? So I think it's good to kind of that every question generates 10 more questions. That keeps life interesting.
It does. Thank you so much, Erik Meijer, for chatting with me today. And this has been another episode of Hansel Minutes. We'll see you again next week.